Hello everyone. So, let us continue our discussion. We are in week 4 and this is the lecture 2. So, today we are going to solve a problem on plane stress. We earlier already solved some problem for 2D, but let us quickly revisit. So, plane stress. Example. So, what we have is sigma xx is equal to 12 MPa, then tau xy is equal to 7 MPa, and then find sigma n and tau n acting on a plane whose angle alpha is equal to 30 degree with respect to positive x direction. So, if I draw the stress block, we have sigma xx, that is 12. There is no sigma y, we only have tau So, that is the stress block, and here we have 7. Now, if you recall, we have already derived the expression for sigma n, and that is n x square sigma x x plus n y square sigma y y plus tau x y. We have actually 2 times n x and n y. Okay. Now, for the given angle, n x is equal to cos of alpha, which is 30 degree, and then n y, which is sine of alpha, that is 30 degree. So, we know the values of cos and sine alpha. So, cos of 30 degree, which is 0.866, and then sine of 30 degree, that is half, right. So, 0.5. Obviously, if we put that expression here, we have 0.866 square times 12 plus 0.5 square times 0 plus 2 into 0.5 into 0.866 times 7. So, that is the expression. So, if we estimate 0.86 square times 12, so the first term is 8.99 plus we have 2 into 0.866 into 0.5 into 7, and that is 6.06. Together these two gives 8.99 plus 6.06. So, it is 15.05 MPa. And tau n, if you recall, actually we get it from the traction. So, t square minus sigma n square root of this quantity is tau n, right. For that, we have to first find out T x, that is equal to sigma x x times n x plus tau x y times n y. So, sigma x x 12, nx is 0.866 plus tau xy 7 ny 0.5. So, if we calculate this quantity, so we have 12 into 0.866 plus 7 into 0.5. So, that is 13.89 MPa. Then Ty, we have tau xy times nx plus sigma yy times ny. So, we have 7 times 0.866 plus 0 times 0.5. So, what we have 7 into 0.866, that is 6.06 MPa. Now, if we bring them here, we have 13.89 square plus 6.06 square minus 15.05 square. So, if we solve this quantity, 13.89 square plus 6.06 square minus 15.05 square. So, square root of 3.1532 and this is equal to 1.78 MPa. Okay. So, we have the normal stress and shear stress acting on a plane given by this angle alpha equal to 30 degree. Now, for 2D problem, if you recall, we derived another expression sigma n is equal to sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos of twice alpha plus tau xy sin of twice alpha. And then tau n is equal to minus sigma xx minus sigma yy divided by 2 sin of twice alpha plus tau xy cos of twice alpha. You can directly estimate normal stress and shear stress for 2D problem using these two expressions. So, I leave this as an exercise. In the previous lecture, we actually started from this expression and derived this quantity. So, they two are same. Just for cross verification, I leave this as a home task for you. Right. So, the first part is now answered. So, let us check what should be the Mohr circle for this problem. Okay. So, for that we have the stress block 12 and then 7 . So, that is 7 and this is 12, right. Okay. So, we will first find out the principal stresses and for that we have sigma 1 comma 2, we have two principal stresses and then their expressions are sigma xx plus sigma yy by 2, then plus minus square root of we have sigma xx minus sigma yy by 2 whole square plus tau xy square, right. Actually, this quantity is sigma average, if you recall, and this quantity under square root, this is r, right. And center is sigma average comma 0, and then we have radius r. So, let us first find out sigma average, which is in our case 12 plus sigma y by 0 by 2. So, this is 6 MPa, and r is square root of again 6 square plus 7 square, right. So, this is equal to 9.22. Okay. So, that is the again MPa. Recall tau maximum is nothing but r, right. So, this is 9.22 MPa, and then we have sigma 1, 2, for that we have 6 plus minus we have 9.22. So, one is 15.22, another is minus 3.22, right. So, these are the two principal stresses, and then we have to draw the Mohr circle that we can easily now draw. You see, the moment we find out the two extreme values of principal stresses, the first one is somewhere here 15. So, 15.22, and the second one is minus. So, somewhere here. So, this is minus 3.22, and actually if we take the average of these two, we will get somewhere here, and that is the center point of the Mohr circle, right. And then obviously, if we draw the circle, this is basically the circle. I draw it half of the circle because that will do. So, here this is our sigma average comma 0, that is the center, and this point at the extreme so this is basically tau max, and here it is, this is the r that we have estimated, right. So, we have sigma and tau axis, and we can complete the circle. It is actually not always drawn because we can easily complete the other half. So, that actually forms the circle which gives the complete variation of stress and normal stress and shear stress over different planes, right. Earlier we identified sigma xx, tau xy, and then we actually identified this point, and then we have sigma yy 0, and so this is tau yy, and if we join these two, then that passes through the center, and then we consider half of this from center to this extreme point. This is the x face. So, this is our r, and with that we can draw the circle, but today because we have already estimated the principal stresses, then with the help of that we can easily draw the Mohr circle. So, that completes the solution for this problem, and you have seen that for a given stress field, if we have a special case where all the z component of the stresses are 0, then we end up with a plane stress condition. And I already discussed the examples also. If you have a plate, very often we deal with this type of problem in engineering. So, if you have all in plane loading, then we actually end up with this type of problem, and we derived the expression for stresses and their maximas. So, this is a case of plane stress, right. And today we have solved example, we have drawn the Mohr circle also. So, you can completely solve this problem. We will have some questions for you. So, you try those questions. If you have any difficulty, please raise your difficulty through email, or we are also going to have a open session. There also we can discuss all the difficulties that you have. With that, let me close here. Thank you very much.